All right, algebra. Last set of examples on adding and subtracting rational expressions. So I got three of them here. So look at our first one. We got 5 over c plus 2 plus 6 over c minus 3. So when I look at these, I can see they're different denominators. One of them c plus 2, one of them c minus 3. Now, and they're binomials. It's not just one term on the bottom. So basically what I'm going to do is I'm going to multiply by the other denominator. So what I mean by that is this. On the left here, I'm going to multiply by c minus 3 over c minus 3. And by doing that, so up top, I'm going to do 5 times c minus 3. I'm going to distribute that. That ends up being 5c minus 15. And that's going to be over c minus 3 times c plus 2. I'm not going to multiply that out. And then up top here, this is going to be, I'm going to multiply this one by c plus 2 over c plus 2. And by doing that, I end up getting 6c plus 12 when I distribute 6 times c plus 2. And on the bottom, I've got the same thing here, c minus 3, c plus 2. I'm running out of room. So now you can see I've got common denominators. Both of them are c minus 3 times c plus 2 on the denominator. So now I can add, because I got common denominators, 5c plus 6c is 11c, negative 15 plus 12 is negative 3. And that's all going to be over c minus 3 times c plus 2. I don't need to multiply these out because I can see I'm not going to be able to factor anything here. I'm done right there. And there is my answer. So when you have binomials on the bottom like that, a lot of times you're just going to multiply the other, you're going to multiply by the other denominator. So let's look at the same next one. Same idea here. I've got two different denominators. I got 2m plus 1 and m minus 1. So I'm going to multiply this first side by m minus 1 over m minus 1. And when I do that, m times m minus 1, I'm going to distribute that. That's going to be m squared minus m. Because m times m is m squared. M times negative 1 would be negative m. And that's all going to be over m minus 1 over 2m plus 1. Then over here, I'm going to multiply this one by 2m plus 1 over 2m plus 1. I do that, so I distribute the 3. 3 times 2m is 6m. 3 times 1 is 3. And that's all going to be over. I'm not even going to rewrite it again. It's going to be over the same denominator. Now I can combine. So I can add because I've got common denominators. I've got m squared. I have no other m squareds here, so it has no like terms. So I'm just going to say m squared. Then I've got negative m plus 6m. That's positive 5m. And then I've got no number here plus 3. That'll be plus 3. And then on the bottom, I've got m minus 1 times 2m plus 1. So basically now I got to make sure, can I factor the top? Can I factor it and get one of these two to cancel out? Actually, when I look at m squared plus 5m plus 3, I don't think that's factorable. Because the only way to get 3, if I were to, it would be, so it'd be m times m. And the only way to get positive 3 would be plus 3 plus 1, 3 times 1. But when I add up my outer and inner, 1m plus 3m, that's 4m, not 5m. This is not factorable, so my answer is right there. All right, let's look at the last one. I left the last one. The last one's kind of tricky. So I got k minus 24 over, it's over a trinomial, minus 3 over k plus 3, plus k plus 1 over k minus 6. I can clearly see I don't have any common denominators. But what I'm going to do is I'm going to start by factoring this trinomial and see if anything jumps out at me when I do that. So when I do that, I'm looking at negative, so this is going to be k, this is going to be k. To get negative 18 would be 6 times 3, 1 positive, 1 negative. I can see this is a minus 3k, so I bet it's going to be minus 6 plus 3. That would be negative 18. I check outer would be 3k, inner would be negative 6k. 3k plus negative 6k is negative 3k. I factored it, and interestingly enough, it's the two denominators I have, so that's going to be helpful. So this is all still the same. All right, so I've now got my denominator where this is k minus 6 times k plus 3. This is just k plus 3 as the denominator. So I multiply that one by k minus 6 over k minus 6. I would then have k plus 3, k minus 6 on my denominator. So this one, I'm just going to kind of write in here. I'm going to multiply by k plus 6 over, or sorry, k minus 6. That's a typo. All right, let's try this again. So if I multiply this one by k minus 6 over k minus 6, I'm then going to have this same denominator as I do in my first fraction. Over here, this one, k minus 6, if I multiply it by k plus 3 over k plus 3, I'm going to have the same denominator as well. So now I'm going to do all that. So this first one, I have k minus 24 over k minus 6 times k plus 3. That one just stays exactly the same. Over here, I'm going to multiply 3 times k minus 6. That'll be 3k minus 18. And that's going to be over blah, blah, blah. I'm not rewriting it all. It's going to be over k plus 3 times k minus 6, the same denominator. And then the last one, this one's a little tricky. I've got k plus 1 times k plus 3. I got to FOIL that. I got to do first, so that would be k squared. And then I got to do my outer and inner. That would be 3k plus 1k, which would be 4k. And then 1 times 3, which is 3. And again, that's all over the same denominator, k plus 3 times k minus 6. Now I can finally add and subtract and combine all those like terms. I'm going to start with my k squared because I want these in order. I have no other k squareds anywhere, and this is plus k squared, so it's positive. Then I'm going to move on to my k's. I have k minus 3k, which would be negative 2k, plus 4k. Negative 2 plus 4 would be positive 2k. Then I'm going to move on to my numbers. Negative 24 minus negative 18, that'd be like plus 18, that'd be negative 6. Plus 3, negative 6 plus 3 would be negative 3. And all of that's going to be over k minus 6 times k plus 3. Woo! A long problem. So now, are we done? Let's make sure we can't factor this trinomial up top. So that would be k, that would be k. So negative 3, one's going to be positive, one's going to be negative. What if I did plus 3 minus 1? That'll be over k minus 6 times k plus 3. Let's double check that I did that right. My outer would be negative 1k, my inner would be plus 3k. Negative 1k plus 3k is positive 2k. So I did do it right, and you can see I got a k plus 3 and a k plus 3 that can factor. So I actually get a final answer of k minus 1 over k minus 6. Whew, that was a lot. All right, there's your examples. You got some practice problems. Do those. Check them with the answer key. Then do the quiz in Google Classroom. Thank you.